this video we will discuss the problem find length of loop in a linked list. Previously this problem has been asked in Adobe and Amazon. So the problem says that you will be given a linked list that will consist of n nodes and you have to check whether a loop exists in the linked list or not. If the loop exists in the linked list, then you have to return the length of the loop, otherwise you have to return 0, right? So this is what you have to do in this particular problem. Let's try and take some examples. So if I tell you like this example, 1, then 2, then 3, and then 4, and then 5, and let's say this 5 is connected to this 2, right? So in this case you can see that the length of the loop is nothing but 4. This is the first node, right? This is the second node, this is the third node, and this is the fourth node. So total 4 nodes are there in the loop, right? So this is what you have to do. Now let's suppose that if instead of this, if this linked list looks like this, so in this case you will say that there is no loop existing in the linked list, right? So there are 2 targets that you have to do. First of all, you have to find that whether there is a loop existing or not, right? The first target is that you have to find that whether there is a loop that exists in the linked list or not, right? So does the loop exist or not? That is what you have to check first of all. And if it exists, then you have to find its length, right? If it does not exist, then you will simply return 0, right? Otherwise you will return the length of the loop by finding its length, right? So this is what you have to do in this particular problem. So what is the concept behind this, right? So the concept is said to be fast and slow pointers. Let's try and understand what do I mean by that. So basically, suppose that there is a linked list, right? Suppose the linked list is like 1, 2, then 3, and then 4, and then 5, and then let's say 5 is pointing to null, right? Suppose this is the linked list that has been given to me. So in this particular linked list, I can easily observe that there is no loop existing, right? So how can I check that? So suppose that the concept is that what I can use is, I can use the concept of fast pointer and a slow pointer, right? I'll have a slow pointer and I'll have a fast pointer, okay? So these are the 2 kinds of pointers that I'll have, and the slow pointer will move by 1 and the fast pointer will move by 2, right? So what does that mean? So basically, if there is no loop, if there is no circle, right? If there is no loop happening, so in this case, if there is a linear path, right? If there is a simple linear path, in that case, if one person is traveling at the speed of 1 kilometer per hour, let's say, right, and second person is traveling at the speed of 2 kilometer per hour, then this means that these 2 people will never meet, right? If there is no loop, if there is no loop existing, in that case, if one person is traveling at twice the speed of other person, in that case the person who is traveling faster will reach the end first, and the slow person will only reach the half distance, right? So the concept is that if there is no loop existing, then the fast and slow pointers will never meet. But if that is not the case, then in that case they will meet. So first of all, let's check when they will not meet. So let's suppose that this is the case, and I have the slow pointer and I have the fast pointer, right? So initially slow will be at 1, fast will be at 1. Slow travels by 1, so slow will move to 2. Fast moves to 3. From 1 it moves to 3. It takes a jump of 2, right? After this, what happens? Slow moves to 3 and fast moves to 5, right? Now you can see this part. Fast first of all move from 1 to 3. And then from 3 to 5, right? Now you can see that if fast takes a jumps of 2, then it will fall out of the linked list, right? Because fast.next is not available, right? Fast next is null. So you need to check, right? You can see this part, that if fast next is equal to null, right? If fast next is equal to null, in that case you can simply return 0, because that means that fast has reached the end, because fast is currently standing here. And if fast next is equal to null, so that means that this linked list does not have a loop, right? So in that case you can simply return a 0, right? So this will be the case. But there can be one more situation. Suppose that the length of the linked list that we are considering, is kind of even, right? In that case what will happen? 1, then 2, then 3, and then let's say 4, then let's say 5, 6, and null, right? If this is the case, so in this particular case what will happen? I'll have the fast and the slow pointer. So slow and the fast pointer I'll be having, and slow pointer will be pointing to 1, fast will be pointing to 1. Then slow moves by 1, fast moves by 2. Then what happens in the next step? Slow moves by 1, fast moves by 2, right? So from this 1 it reaches 3, right? Earlier it reached from 1 to 3 and 3 to 5, right? And it could not move further, because if fast next is equal to null, then I cannot move, right? And that means that I should return 0. In this case you will see that from 1 it moves to 3, from 3 it moves to 5, and from 5 can it take one more step? Yes, it can take one more jump, right? It can move to 6, it can move to null. So in this case slow will move to 4 and fast will move to null, right? So in this case you can see that earlier what was happening was, earlier my fast next was becoming null. If my fast it is an odd length linked list, so in that case I can see that if my fast next is equal to null, then I should terminate and I should return 0, right? In this case I should return 0, right? Or if it happens that my fast is directly pointing to null, if my fast is equal to null, in that case I should also return a 0, right? These are the two cases when my this is the first case and the second case when my linked list does not have a loop, because one person is traveling twice the speed of other. So if there is no loops, and then they will never be meeting, and in that case either fast next will be null or fast will be null, right? So this will be the case when the loop will not exist. But suppose that the loop exists, right? So in that case what can I say? So let's take example for that as well. Let's take this example. Let's say 1, then I have 2, then let's say I have 3, then I have 4, and I have 5, right? And let's take this example. So the example says that 5 is connected to 2, right? So let's connect these two guys, right? So in this particular case what you will observe is I'll have the slow pointer and I'll have the fast pointer. Okay, initially both will be starting at the head. So 1, they start from 1, slow moves by 1, fast moves by 2, so fast moves to 3. After that slow moves to 3 and fast moves to 5, right? From 1 it moves to 3 and then to 5, right? From 5, like now currently my slow moves by 1 again, because the fast next is not null. So neither the fast is null nor the fast next is null. So slow moves to 4, right? From 3 it moves to 4, and fast was currently standing at 5, right? So if it moves, it always takes a jumps of 2, right? It always takes a jumps of 2. So if it is standing at 5, so it will take jumps of 2. So if it takes jumps of 1, so it will reach to 2. If it takes jumps of 2, so it will reach to this node 3, right? So it reaches to this node 3. Now what does happen? So you can see that my slow moves to slow points to now my slow points to 5, right? The moment my slow points to 5, because it moves by 1. So what happens? Currently fast is standing at 3, right? Fast is standing at 3. From 3 my fast moves to 5 as well, right? So you can see this part, that what happens is you can observe that my fast and slow are meeting, right? Fast and slow are meeting. Fast is equal to slow is happening, right? So if this happens, so in that case what you can say is that if fast and slow are equal, then you can say that you keep your fast here only, right? You keep your fast here only and you mark your count as 1, right? You keep your fast as constant. You keep your fast pointing to 5 only, right? You keep your fast pointing to 5 only, right? You keep it at the same place and you mark your count as 1, right? Because at least one node is there in the loop. Now what you do is you move your slow by 1 eventually, right? Every time you keep on moving by 1, right? So since your fast is equal to 5, now the count is what? The count is nothing but 1 here. What happens next? The slow moves to 2, right? Slow always will be moving by 1 until it's equal to fast. So slow is equal to 2. In that case you say that this slow is not equal to fast. In that case you mark the count as 2, right? You increase the count by 1. After that slow moves from 2, it moves to 3. So since it moves to 3 from 2, so in that case you can say that the count also changes to 3, right? After that it moves to 4. The moment it moves to 4, so what happens? So in that case there is one more node that is not equal to the fast. In that case you will increment, so slow moves to 4 and the count also changes to 4, right? Total 4 nodes, right? So you can see this part, that is the after this what will happen? The slow moves by 1 more, so slow points to 5 now. Now the moment slow points to 5, so you can see that fast and slow are same. So in that case you will terminate, right? And what is the length of the loop? The length of the loop is nothing but the count, that is nothing but 4. And you can see this part, the loop is what? 2, 3, 4 and 5, and basically there are 4 nodes inside the loop, right? That's why the count is coming out to be 4. If you want, we can check out another example. Let's try and see for a bigger example. Let's say if I take 1, then I take 2, then I take 3, 3 to 4, 4 to 5, and 5 to 6, then 6 to 7, right? And let's say the example that I'm taking is this, right? If this is the sample example that I'm taking, so in this particular case you will be able to observe that first of all I'll require 2C, right? So fast and slow I'll be having as the pointers, and initially fast will be pointing to 1, slow will be pointing to 1, then slow moves to 2, fast moves to 3, slow moves to 3, fast moves to 5, then what happens? Slow moves to 4 and fast moves to 7, right? After this part what happens? Slow moves to 5 and then fast moves to what? Fast moves to 4. After this what happens is slow moves to 6, right? It moves by 1 and fast is standing at 4, so it moves by a distance of 2, so fast moves from 4 to 6, right? And you can see that 6 is the intersection point of both, right? So you can see that 6 is the intersection point. So I'll say that okay, let's fix my fast to add let's fix the fast at this particular node 6 only, right? Let's fix my fast to this particular node 6 only, right? And after that what happens is my slow will move, right? I'll mark my count as 1 because at least one node is there inside the loop. After this, what will happen? I'll move by 1, right? So from my slow currently was standing, which was standing at 6, now it stands at 7. So the counter changes to 2. After that, from 7, it moves by 1. So it moves to what? It moves to this node 3, right? After this, it moves to this node 4. Right, so the count total will keep on incrementing, so it changes to 3, then changes to 4. Then after that, what happens? From 4 it changes to 5, right? So the slow is pointing to 5, and basically that means that there are total 5 nodes, right? Because 1, 2, 3, 4 and 5, right? You can see total 5 nodes were there. Now after that, my slow points to 6, and that is nothing but slow is equal to fast again. So in that case, I'll say that I'll return the count, that is nothing but 5 nodes, and you can see that they were actually 5 nodes, right? You keep your fast as 6, and you keep on moving by initializing the counter to 1. You slow moves first of all to 7, then 3, then 4 and 5. So your count gets incremented 4 times. So that means total count was initially 1 because you were standing at this node, slow was standing initially at this node. So total number of nodes, that is nothing but the count is equal to 5, and that is the length of the loop, right? So that's how we have to implement this particular question. Let's quickly write the code for this particular problem. So what I'll be having is, I'll be having the fast and the slow pointer. So I'll say that node star slow is equal to nothing but head. I'll point initially both of them to the starting, and node star this thing fast is also equal to head of the linked list, right? After this is done, so what I'll say is, initially I will think that I can mark the count, let's say, as 1, right? Initially I'll think that let's mark the count as 1, although you can do this inside the loop as well. So maybe we'll do inside the loop, that will be perfect, right? After this, what you will say is that you will run until your fast is not equal to null, right? Until your fast is not equal to null and your fast next is not equal to null. So both of them should not be equal to null, right? If any of them fast, neither my fast should be equal to null nor my fast next should not be equal to null as well, right? So both of them should not be equal to null, right? And if none of them are null, then in that case I'll keep on moving, right? The moment any one of them becomes null, in that case I will simply terminate and return 0, right? So if I come out of this loop, so that means I have to return 0, because if this loop terminates, so in that means that there is no cycle existing, and in that case I have to return 0 because the length of the cycle is 0, right? Because there is no cycle existing. So I'll move my slow by 1. So slow is equal to nothing but slow's next, right? Slow will move by 1, and fast is equal to nothing but fast's next, right? So this is what will happen. Basically they will keep on moving by 1, right? And if it happens that my slow is equal to fast, if the slow pointer is equal to the fast pointer, in that case what will I do? I'll mark my count as 1. So I'll say that int count is equal to 1, right? After this part, I'll run a loop until my slow is equal to fast, right? So while slow is not equal to fast, but before that I need to move my slow pointer by 1. So slow is equal to slow's next, right? So that is what I'll do. I'll move my slow by 1, right? And I'll mark initially count as 1, and I'll run until my slow is equal to fast. So what I'll do is, every time I'll keep, if my slow is not equal to fast, so I'll keep on counting the number of nodes, right? That is nothing but the length of the loop. After this, inside the loop as well, I'll keep on moving my slow pointer by 1. Slow is equal to nothing but slow next, right? And after this part is done, so after the slow and fast become equal, so that means I have found the length of the loop, and I can simply return the count, right? So this is what I'll be doing. Let's try and compile and see if it works on the samples or not. So you can see that for this sample example, we are getting the length as 7. So let's quickly submit this code and see if it gets accepted. So you can see that this particular code was able to pass all the test cases, right? So this is how you do this particular problem. And talking about this problem, so as you know, it has been asked in Adobe and Amazon. So this is how you do this particular problem, and the time complexity for this particular problem is going to be order of n, right? The time complexity is going to be order of n, because what we did was we used the concept of we just had to iterate at least once through all the nodes, right? So that's why it was order of n, and the space complexity would be order of 1. In case if you like the explanation, the detailed explanation, so you can make sure to like the video and comment down understood in the comment section as well. Thanks a lot for watching.